Hey, what's up everybody? In this video tutorial, we're going to be taking a look at how to create a parametric pear cam. All right, we're going to be using this for our pool toy project. So what you're going to need is your cam dimension drawing reference sheet that we see here on the right-hand side of the screen. And when we take a look at the pear cam here, we can see that the dimensions that it's giving us are not your typical dimensions found within a working drawing. And the reason is that you kind of start analyzing this a little bit more. You're looking at fractions and you're looking at like letter references like D, and you're looking at static dimensions like 3/16 and so on. But the thing is, you're really kind of looking at variables here, all right? And these are things that can change. They're going to have an impact on other things within that actual drawing. So I'm going to be referencing this. So make sure you have that in front of you as you're going through this actual video tutorial. So I'm going to go ahead and just slide that right off the screen here. I'm going to go ahead and I'm going to be opening up a standard inch IPT. That's what I have going for me right now. So in order to get things started, I'm going to come up here, go to manage. I'm going to go into parameters. And you can see we have model and user parameters here. I'm going to pick on add numeric. I'm going to be creating my own user parameter. And the first thing I'm going to do is just type in DIA for diameter. All right, that's what we're going to be referencing to these dimensions. I'm going to come out and go into equation. This is just going to be a dimension. So in my first case, I'm just going to put in a placeholder right now, like 1.5 inches. All right, because you can see in the actual assignment that the all the cams are going to be coming in sizes of 1.5 inches, 2 inches, 3 inches. So we're going to start with the smallest one of 1.5 inches. I'm now going to come down and add a new numeric, and this is going to be hole. All right, this is going to be the actual axle hole that runs through it, and the size of the dowel rod we're using is actually 1/4 inch. All right, so that's going to be a static dimension of 0.25. I'm going to add a third numeric, and this one's going to be THK. This is going to stand for the thickness of our plywood. In our case, 0.1875 or 3/16 of an inch is the actual thickness of the plywood. So there you go, just that fast. We have our diameter parameter, our hole diameter, and our thickness diameter, and we have measurements for all those. So I'm going to go ahead and just hit done on this. Go into my 3D modeling environment, start a 2D sketch, and pick on a plane. All right, so the first thing I'm going to do is come out here and draw a circle starting from the origin. Okay, so you can see going in, the default setting is going to be diameter. But when we take a look at the actual cam dimension drawing, it's referencing this as a radius dimension. It's saying it's going to be half the diameter. So while I have dimension going, I'm just going to right click and come down. You can see radius is one of those options that I have. Now we can even see how this has changed a little bit. All right. So now it's asking for radius. So I'm going to type in DIA times 0.5. All right. So it says in the cam dimension drawing that a radius is going to equal half the diameter. So it's just going to be diameter times 0.5. I hit enter. All right. We can see the FX is indicating that this is referencing one of the parameters I set up earlier. All right. And it's just telling us it's going to be half of that, which would be 0.75. All right, so now what I'm going to do is I'm going to create a circle. Now when I do this, I'm going to track off of the center point. I'm just going to hover over for a second, make sure that this goes vertical. I'm going to go ahead and draw this circle here on top. All right, so now it's asking for a radius to be a quarter of the diameter. So what I'm going to do is just take my DIA and I'm going to multiply that by 0.25. All right, so that's been set up. All right, in order to make sure that this is vertically aligned between this center point and this center point, I'm going to come up here, go to my vertical constraint, pick the center point of my small lobe, and then pick the center point of my large lobe. All right, so when I come back in and grab this now, we can see it can only slide vertically. It's doing exactly what we wanted it to do. All right, so now I'm going to come in and pick a dimension, and I'm going to put this dimension here at the center point and go to this center point, pull this over, and this is going to be DIA. In our case, our cam dimension drawing is saying that's going to be half our diameter. So DIA times 0.5, I hit enter, and now that brings it right up to that point. All right, so now that we're done with that, I'm going to go ahead now and create a line. And I'm going to extend the line beyond the actual lobes of the cam. I'm doing that intentionally, just to make sure we have enough material there to work with what we want to do. All right, so now I'm going to come up, use tangent. I'm going to pick the circle and then pick the line. You can see how there is now a tangent point between those. I'm going to do the same thing down here below. So we have two tangency points, that flat line and those lobes. I'm going to do the same thing here and then do the same thing here. I obviously I'm not going to be needing these ends on the end of it, so I can come up here and use trim, and I can just trim those out. Okay, just like so. Last thing I need to do is come in and add a circle starting from this center point. The problem is that this is still setting on radius. So I'm going to right click and switch this back over to diameter. Okay, and now all I have to do is type in hole. And that's going to be the diameter of the hole that we have set up earlier. Okay, so I'm done with my profile. I know we could trim and do all that stuff. We're not going to. I'm going to recommend you don't do that because this can really start tearing things up with our dimensions. So let's just go ahead and finish the sketch. Do a little zoom extents here. And now I'm going to come in and go to extrude. So I'm going to make sure to grab all the profiles. This can be a little bit tricky, so make sure you're grabbing everything. And the other thing on cams is when you're going to extrude cams, go ahead and do a symmetrical extrusion. The reason is later is that we can have a work plane going right down the center of that cam, and we can have that actually line up with the follower. That's going to be a huge help for us later. So always go with symmetrical. And the distance we're going to use for our extrusion is going to be THK, which is going to be referencing the parameter that we set up earlier for thickness, which in our case was 0.1875. I'm going to go ahead and say OK on that. And yeah, there we go. We have our Pear cam ready to go. This is the point when you can come up and begin applying your material to it according to what our assignment is. But let's just go ahead and let's just actually see if this works. So I'm going to go ahead and pull this over, go up to manage, go into parameters. Okay, and now we can start adjusting our user parameters. So in our case, our project was saying we could have 1.5, 2, or 3 inch. I'm going to switch this from 1.5 to 2. I'm going to go ahead and hit enter. And now we can see that the size has just grown. I'm going to do this one more time. Switch this up to 3 inch, hit enter, and now we can see how that's grown as well. All right, not only is the actual size of this growing, but you can see that the center points from the large lobe to the small lobe, they are increasing as well because they are referencing our diameter, which in our case, to begin with was 1.5. We're switching that up, so therefore it's growing as well. All right, I'm going to send this back down to 1.5 inches. Send this back down to 1.5 inches, bring it back down to where it was, and let's even go smaller than that. Let's go down to 3/4. All right, we can see that worked for us as well. Okay, so I'm going to go ahead and send this back into our small size, which was 1.5 inches, and say done. And here's how you can quickly create a part library. You can go up to File, go to Save As, and I'm just going to call this one Pear Cam, and I'm going to say 1.5 at the end for 1.5 inches. Okay, go back up to Manage, go into Parameters, switch this up to 2. Okay, hit done on that. Go out to File, do a Save As. Okay, we can just piggyback off the last one, which was here, and just say that this is going to be 2.0, which stands for 2 inch. And then go up to Manage one more time, go into Parameters, and we can set this one up for 3. Okay, once again, we can do a Save As. Okay, go to our Pear Cam, switch this up to 3.0, standing for 3 inches. Okay, we could do a save. All right, so just that quick. All right, we have set up a cam that's not just parametric, but we went out there and actually just spit out 3 different files. It's all set up for 1.5, 2, and 3. All right, just a great way you can do that. All right, so there you go. That's how you create a parametric Pear cam for our Pull Toy project.